Great. Thank you, Brittany. So hello, welcome. I am Kristen Smith. I am a math instructor and curriculum writer. Joey, we kind of work as a team a lot with professional development, and he's going to be helping me out, help monitor the chat, and monitor the Who chat in case anybody forgets to use the Zoom, but try to use the Zoom chat. And we're going to be chatting quite a lot in this. So Joey, you want to talk a little bit?
Hey, good morning, everyone. It's so great to be here at this year's Forum for Excellence. This is our second year presenting. And my role primarily is as Program Effectiveness Coordinator in adult education. So I have a background and a career in adult ed. And I'm excited to connect with all of you today. So thanks for being here.
Thanks, Joey. So I'm really excited to start talking to you guys. Just checking in. Feel free to pop into the chat and let us know how you're feeling today, because this has been quite an interesting couple of years, and not every day is the perfect day for a morning virtual conference. So let's check in with everybody. How are you today on this graph here? Energetic and positive in quadrant 1, energetic quadrant 2. Maybe you're sleepy, so maybe you're down below the x-axis. All right, so we've got, oh my gosh, a lot of quadrant 1s. Good morning to all of you quadrant. I guess this is a morning session. This is where the quadrant 1 people are, but then there are some 4s. So thank you, the 4s. Maybe you're not a morning person, but you're still here and you're still feeling it. So I appreciate y'all being here today. Nice. Okay, so a lot. I like, we're really all skewed over to the right of the y-axis. Had your coffee, gotcha, 4 all the way. I haven't, nobody is admitting to being in 2 and 3, but maybe if you're in quadrant 2 or 3, you're not feeling up to even sharing. So we welcome you as well, all of you quadrant 2 and 3 folks. We are going to be, talking about math today. So if hopefully everybody is being honest about being over in quadrant 1 and 4, because I know sometimes there are some memories that aren't so great of math class, and so some of that trauma gets brought up. Speaking of, if you could drop in a chat something, a brief memory. Now this could be positive, this could be negative, anything, something you remember from math class or about math class. Take a minute to think. Drop your answer in the chat. Worksheets, so many worksheets. Oh my gosh, Mandy. Really though, I feel you. When I first became a math teacher, that was my main thing that I wanted to solve. My main problem I was trying to solve was like, stop with the thousands of worksheets. Okay, and then Nicole mentions I love math until, and then there's always something after the until. So Nicole, I don't think you're alone. I love math until blank, and that sometimes happens with our math histories. So many rules to follow, memorizing. Oh, okay. So I'm seeing. I saw a word stressed. So someone remembers not being too smart. So we want to talk about that with the growth mindset, because everyone can be a mathematician. Gosh, wow. Thank you all so much. I remember it being natural and easy until it wasn't. There's that word until again. So that does come up, homework every night. So gosh, yeah, love math until, and we have that. So I remember taking the time to explain it over and over. Okay, nice. All right, I love Bill. All right, we got a math fan here in Bill. please continue. If you haven't, if you've thought of a brief experience and you haven't put it in there, I love looking back at the chat after. This is the question that has come up in my teaching life and in my life in general, is connected to that story. How do I convince everybody else that math isn't everything and that they already do math? Because a lot of people have this experience. I love math until, or a lot of people have some negative math experiences, and they're not really convinced that they even do math on a daily basis, or think in a mathematical way on a daily basis. So I'm a big believer in the fact that everyone does math and thinks about math all the time, that they just don't call it math. These are the first two sentences of the very first standard for mathematical practice. This is in the Common Core standards. This is also in the CCR standards. This is corroboration for me. The standards say that doing math is making sense of problems and persevering in solving. So I understand that all my students don't make sense and persevere in all areas of their life, because I don't. But they are adults who have somehow survived thus far. So they have analyzed constraints, analyzed givens, analyzed constraints, relationships, and goals for something, even if it's just how to get this look in 5 minutes. Or obviously this year and last year, there were even more important ambiguous decisions our adult learners are definitely making. But in math class, not so much. I don't generally see a lot of persevering and making sense of in math class. Here a couple of recent quotes. So a student said, "Is this right?" My group of teachers, you can raise your virtual hand. How many of you have heard somebody say, "Is this right?" And then I have a student, "Oh, I'm wrong. I know it. Am I wrong?" Students consistently show me that I, as a teacher, have power, and they, as students, do not. So my question for you all, which is why I am talking to you all today, because I'm hoping that you can figure out the answer to this. I have ideas, but really I'm putting this question to you. How do I convince students that they already do math? And then also, how do I connect the math that they're doing to test math, right? That's the whole thing, that's the difficulty. So to help us unravel both of these puzzles, first I want to start by thinking about a little bit of the math that we sometimes ask students to do. So more in the chat, you could look at this. This is a type of problem that we generally give students. Can you put in the chat some errors that you've seen? So if you put this to a student, what are some errors that that are similar to errors you've seen students do? Go ahead and throw them in the chat. Okay, right. Yes, this is a subtraction. They subtract 3 from 18. Thanks, Melissa. Improper fractions scare them. Okay, yeah. So maybe if they get to a point in solving this where they might see 15/7, that's really scary. Or if they subtract it, or 21/7, that's really scary. Yeah, so subtracting 7 instead of dividing. Okay. Oh, gotcha. They just, Michael, yes, x equals 3. Just, okay, I see x dash 3, right? This language is weird. It's not a language that we use every day. after adding the 3 to get 21. Okay, so maybe they didn't subtract, they correctly undid the subtraction, and so they have 7x equals 21. Then they all, oh yes, they subtract 7x. Combining unlike terms, great. So this is the question that has come up in my teaching life and in my life in general, is connected to that story. How do I convince everybody else that math isn't everything and that they already do math? Because a lot of people have this experience. I love math until, or a lot of people have some negative math experiences, and they're not really convinced that they even do math on a daily basis, or think in a mathematical way on a daily basis. So I'm a big believer in the fact that everyone does math and thinks about math all the time, that they just don't call it math. These are the first 2 sentences of the very first standard for mathematical practice. This is in the Common Core standards. This is also in the CCR standards. This is corroboration for me. The standards say that doing math is making sense of problems and persevering in solving. So I understand that all my students don't make sense and persevere in all areas of their life, because I don't. But they are adults who have somehow survived thus far. So they have analyzed constraints, analyzed givens, analyzed constraints, relationships, and goals for something, even if it's just how to get this look in 5 minutes. Or obviously this year and last year, there were even more important ambiguous decisions our adult learners are definitely making. But in math class, not so much. I don't generally see a lot of persevering and making sense of in math class. Here a couple of recent quotes. So a student said, "Is this right?" My group of teachers, you can raise your virtual hand. How many of you have heard somebody say, "Is this right?" And then I have a student, "Oh, I'm wrong. I know it. Am I wrong?" Students consistently show me that I, as a teacher, have power, and they, as students, do not. So my question for you all, which is why I am talking to you all today, because I'm hoping that you can figure out the answer to this. I have ideas, but really I'm putting this question to you. How do I convince students that they already do math? And then also, how do I connect the math that they're doing to test math, right? That's the whole thing, that's the difficulty. So to help us unravel both of these puzzles, first I want to start by thinking about a little bit of the math that we sometimes ask students to do. So more in the chat, you could look at this. This is a type of problem that we generally give students. Can you put in the chat some errors that you've seen? So if you put this to a student, what are some errors that that are similar to errors you've seen students do? Go ahead and throw them in the chat. Okay, right. Yes, this is a subtraction. They subtract 3 from 18. Thanks, Melissa. Improper fractions scare them. Okay, yeah. So maybe if they get to a point in solving this where they might see 15/7, that's really scary. Or if they subtract it, or 21/7, that's really scary. Yeah, subtracting 7 instead of dividing. Okay. Oh, gotcha. They just Michael, yes, x equals 3. Just, okay, I see x dash 3, right? This language is weird. It's not a language that we use every day. After adding the 3 to get 21, okay, so maybe they didn't subtract, they correctly undid the subtraction, and so they have 7x equals 21. Then they all, oh yes, they subtract 7x. Combining unlike terms, great. Yes, things we don't understand, such as fractions and pandemics, they do scare people. Yeah, thank you. Thanks for sharing all of these. That there's many like common errors that we've seen. And I just want you to look. There's a different type of problem. It's a different type of question, but it does get at the same standards. So I'm going to give you a few seconds to read this. Now in the chat, just quickly off the top of your head, what is the same and what is different about these two prompts? Anything that you notice that's the same, anything that you notice that's different. The way X looks different. Thanks for being the first one, Tiffany. Appreciate that. It shows being risky. That's something we value in this forum in all classes. Melissa says freedom. Freedom is different. Interesting. Formatted the same, Bill says. Yeah, so like same structure. We're getting at the same standards, and even the equation is the same structure. Bill is adding a possible solution here. So in these, something that I noticed in things that people were saying is there's a lot that's the same. We see the same structure. So we're really getting at the same type of equation. So in order for students to understand one, since the structure of the equation is the same, they're probably going to understand the other if they truly understand it. And yet, Brittany mentioned freedom. This freedom sort of allows for this creativity, and in the first one, it's a little bit more of an exercise when I've seen students do it. The common errors that everybody mentioned were an error of performing an algorithm. There are some steps, and then they misuse the steps maybe in an incorrect order. And so that's kind of what happens when students have exercises. As the term suggests, they provide opportunities for students to practice. Okay, well, I wanted to just get at the difference between a couple of different types of activities before we start, just to let you guys remember, okay, when I give students this, what happens? Okay, great. But when I go back, if I change the type of problem that I'm giving students, then now they have to make sense of problems. Now they have to persevere in solving them. Okay, great. But do we need to teach people using these modern methods that want people to persevere, that want people to figure out what to do in the face of not knowing what to do? Can we have students reach their goals with just the familiar teaching practice, what we're used to? Probably. Honestly, probably. How many questions can you miss on the GED test? What about the high set test? I know in Illinois, there's a couple of different options for high school equivalency. How many questions can you miss on the high set? So do we need to teach people how to make sense of problems and persevere in solving them when the old methods can allow people to get their high school equivalency? You know, I'm not sure. And the question, before we get really back to the questions that I had, I want to talk about that, because if we're not bought in, you can't help me if no one else thinks that it just getting people to pass the GED or the high set is the goal. This is a great goal, but helping students beyond that might require something different. So I just want you to take a look at this graph, and if everybody could, in the chat, we're doing so great in the chat. I appreciate everybody responding in here. But just what do you notice about this graph? Another question? What do you wonder? There's something missing, so maybe you have a question. Thanks, Nicole. I appreciate you being some of the first, Tiffany and Nicole. No axis labels. Okay, yes. Like, what is the y-axis? Amber, yes, most lines are increasing. Great. Is this related to equity in any way? Okay, very, very good question. I noticed that Christine is wondering. Notice it takes me a bit to take it all in. Yeah, thanks, Kathy. Slopes are different, yeah. Leo, thank you. Great. What 4 groups are these? There's 4 groups here. What is it? What are these colors? There's missing info. Yes, Lynette. So I'm gonna the legend for the, yes, the legend is missing. So I'm gonna give you a bit of a legend. This is the labels for the 4 different colors. So I have not yet told you which label goes to which. So each label actually stands for a type of job. Just as a little creativity session, in the chat, could you, what kinds of jobs might fit in for each? So just think of, on your own, think of one job for each of the 4 sections, non-routine, cognitive. So think of this on your own, and then we'll share. I'll give you a minute. What jobs might fit in each section? Just think of one job for each. Okay. And then now I'm gonna go ahead, if you're still thinking of one job for each, don't let me interrupt you. I'm gonna share a couple things that people are already starting to say. So manual and routine. Somebody said, okay, a manual routine job may be manufacturing. Non-routine cognitive teacher. Yes, please, right? That's definitely a job that is non-routine cognitive. And you're sharing the non-routine cognitive. A plumber, that is not going to be a routine job, right? Not going to be a routine job. Manufacturing is going to, there are definitely some routine manufacturing jobs. I wonder if there are different manufacturing jobs that fit in cognitive or fit in manual. Thank you so much for taking the time to think through this, like what would go in each job. According to where I got this data, the types that they have some types of jobs that fit in each, like anything. So teacher definitely fits in non-routine cognitive management, professional, right? Something that's routine but cognitive, anything sales and office. Just one example, okay? Every example that y'all have mentioned is really, really good, creative. There are lots of jobs that fit into each, but here are some of the occupations that fit in each. So now that we've thought about that a little bit, which is which? What do you think? What are your guesses? Which jobs are which jobs are becoming more necessary as time goes on? And this graph only goes to 2013. I think somebody mentioned that when you were looking at the graph. But from 1983 to 2013, which job is growing fastest? Which one is which? What do you think? Linda is the first to offer a guess. Thank you, Linda. All right, yes. Okay, we have some more guesses. So non-routine cognitive, you think is the, so Bill is saying, all right, orange is the biggest growing is orange. And you would be correct. The non-routine cognitive jobs are growing faster, and there are more persons employed in millions than any of the other types of jobs. Going back to thinking about those different types of problems that we looked at. Can we get students to pass the GED in the high set using our old teaching methods, where the teacher has all the power and the students are simply vessels? Yeah, maybe, maybe. But can we prepare students for college careers and beyond? Can we prepare them to determine what to do in the face of not knowing what to do? Essentially, what non-routine jobs are. I'm thinking not. Exercises like these, even when desired. So a lot of my students look at these and they go, oh yeah, just show me how to do it once. So even when desired, these are not college and career ready work. So back to my questions. My question is how to connect the ambiguity students deal with on a daily basis. They already do it. They're figuring out how to do their makeup. They're deciding whether or not their children should be in school. And I want to connect that ability to deal with ambiguity to math ambiguity. And so I have these questions, and I want your help. I want lots of help answering these questions. I have ideas only. So to help answer these questions today, I do want to have us do some brief mathematical experiences. This is not so much to get the answers, but to have something to talk about afterwards as far as teaching goes. And Adele, I'll acknowledge your question. Does the trend, and just talking about the graphs from before, does the trend show that more automated processes are replacing human muscle power? In these slides will be available after the session, so you can go to this link and have any other questions that we didn't quite get to answered. Let's see. Michael, I'm gonna Joey, if you want to table Michael's question, so that just let me know. Thanks. So first, I want to just do a brief warm-up exercise, brief warm-up math thinking, and we're going to think about the number 10. So I do really love visuals. In life, we do get some visuals when we're thinking about math. So I'm just going to add some visuals about the number 10. Everybody ready? Thinking to yourself, I want you to think using your brain only. If you could put pencils down and just think mentally about this. Everyone think in your own way.
Claro que se puede. Quítale todo. Yo lo arreglo.
What is 75% of 10? Okay, so if you're still thinking, don't look at the chat. There's some spoilers in the chat. Okay, so again, this math is so fun, but not necessarily to get answers. So even though there's some guesses, some spoilers, even in the chat, we're gonna still talk a little bit. So Bill or Rukio or Leo or Ali, people who've already volunteered a guess. Can any of you can do this in the chat, or you can unmute yourself. Talk to me a little bit about how you got your guess. Thank you so much, Leo. Thanks, Amber. Being brave is a very important part of math class. I emphasize it a lot. Like, we really respect taking risks in this class. Okay, so Leo says 3/4 is 7/500. Okay, so just move the decimal. Okay, so what? So 75% of 10. You're moving a decimal. Okay, interesting. I am not quite seeing exactly how Leo is thinking. So think that just mentally, it's part of everyday math. Yeah, but what's going on mentally? Thanks, Pamela, for trying to explain a little more. Some folks like, oh, nice. Okay, so Pam, thank you. You used the fingers. 50, she said 50% is 5 fingers. So I need half of these fingers on the other hand is what she was thinking. So 5 and then half of 5. 2.5. Okay, so Allie, thanks. So what Allie did was use a calculator and converted 75% to 75 per 100 or 7/500. Great. And then, Dee says, I always tell my students to think about money. I find I never have to. They usually are thinking about money anyway, without me telling them. But Dee says, I thought of 3/4 of $10. So 3/4 of $10. But yeah, that's interesting. You just knew that 3/4 of $10 was $7.50. Cool. Each one is 10%. So 75%. Okay, so if 10 is 100%, Laura says, well, each one is 10%. So then she was able to just add 10% 7 times, and then also 5%. That's nice, nice. Okay, so a couple of different methods of looking at this. I can always work from 10% and go from there. Elizabeth is thinking the same way as Laura. Nice. And Diane, a little bit, Diane is similar to, I think it was Pamela who was talking about fingers. But Elizabeth has, Diane has a little bit of a similar way. Half of 10, and then half of 10, right? And that's one way to think about it. So I appreciate you all sharing. couple of different ways of seeing, this is just thinking about the number 10 and 75% of 10, and just with a handful of people sharing, we have many different methods. And even the methods that are similar, there's small differences in them. And so it's, I find it important to share all of those methods. All right, we're gonna clear our mind a little bit. Shift gears. And I want you to look at my next screen and add what you notice. So anything you notice or what you wonder, any questions you have. What do you notice? What do you wonder? I'll give you a minute to read this. Melissa taking risks, Elizabeth taking risks. Thank you guys for being the first to add what you noticed to the chat. Yeah, the alcohol bottle contains more than the recommended. Thanks, Dee. That's a really important thing to notice. Yeah, again, Leo's noticing similar things. Okay. And Melissa is kind of taking it further. She's wondering, how do I take that 99% and make 60%? Interesting. More questions. Christina says, is it okay? Is the solution okay for sanitizing? How much 99%, Pamela says, do I have to use to be safe with 60? Yeah. Adele, I love this question. Like, this is like, now we're getting into more science, right? Wait, what's alcohol actually? And then what is this specific type of alcohol? Yeah. Thank you guys so much for taking time and looking at these and thinking, well, using your brains, like determining what to do here, or what you notice. So I hope that we get to answer all of the questions that came up, and we really might. Some of these questions are similar, but let's. I want to take 3 to 5 minutes, maybe a little bit longer. We might have some time to do some math a little bit longer, and actually answer one of these questions. So let's see. I wonder. So a couple of you are wondering, like, how to take the 99% solution and create a 60% solution. And I'm assuming that, like, in order to get the most use out of it, right? We don't want to use the 99% alcohol if we only have to use 60%. So a lot of you are wondering, well, how can I do this to make the most of that 99%? So here's the question. I'll merge your questions together a little bit. How's that? And maybe it can be something like, yeah. How much, now this is Diane, I'm kind of taking a little bit of what you added there at the end. How much water would you need to add to the 99%? What, how about we'll say that. How much water would you add to the, I guess the whole bottle, right? Is that maybe what you're thinking, Diane? So we'll say that. How much water you need to add to the 99%? Thanks, Diane. So that's what she's thinking. We'll use that. And some of you have similar questions. So thank you, Diane. I'm kind of using you there. How much water would you add to the 99% bottle solution in order to create a 60% solution? So I'm going to give you 3 or 4 minutes. Get as far as you can with this. Okay. Make some progress. We do not have to have an answer here. This time, this 3 to 4 minutes is thinking about math, and that is what we're after. That's the important part here. Thanks, Bill. Hopefully, I think you guys can see this question here. I've brought together a couple of your questions, and we're going to work on trying to answer this question. And I emphasize trying. So you're doing some math. I really recommend having some paper and a pencil nearby. I have a nice handy online whiteboard. So any of you other teachers, if you have your handy online whiteboard, maybe you don't need paper and pencil. But I recommend doing that. I'll check in with you in about 2 minutes. And during this time, we're all just working on this. We're all trying. If you add something to the chat, which I do encourage, right? You want to talk to each other. I recommend that it be like if you have something you're struggling with and you have a question as you're working, you can add it to the chat. Try not to add like a spoiler. Oh yeah, Dee, so Dee messaged me and not the group, but she's saying she was asking how many ounces are in the bottle. So I just noticed that was a little hard to see. Hopefully you guys can see it now, but there are 16 fluid ounces. It's also given in other units. No problem. Okay, hopefully y'all have had some good thinking time and has just gotten as far as you can, making a little bit of progress. That's all we ask for. All right, so if anybody wants to unmute, that might be helpful, but I also am totally fine with you sharing what you can in the chat. So drop it in the chat. How much water would you add and how did you think about it? And if, especially like what this is, this part, that's the answer we wanted, but not quite as interesting. Sharing your thinking, much more interesting. So Dee has like shared this guess. It's interesting, but not as interesting. So tell us, like, what led you to 4.27 ounces? Interesting. Emma says she made a ratio. Adele says, I thought about how much alcohol would be in a 16-ounce bottle to make it 60% alcohol. Okay, oh, interesting. So how much is in the bottle is in ounces at 16. So that's cool. Adele is looking at, okay, if the 16-ounce bottle was 60%, then how much water would that be? Okay, so actually Adele, that's so interesting. That comes to my question. We sort of wrote this question a little differently than my original question, which was how much would I have to pour out to make it 60%? And Adele, you would get there like right away to my question. Elizabeth used a ratio. Pamela's Googling it. Pamela's using a team, including her husband, and she's Googling it. And that, I mean, that is fine. That is interesting. And in class, what I would do is okay, let's do that and talk about, all right, well, what happens when you Google it? What are you Googling? What do you do with those responses? Okay, so Adele, yeah, so back to Adele's method. She's kind of trying to figure out, okay, well, if this bottle was 60% instead of 99%, then how many ounces would be alcohol if 60% of 16 ounces was alcohol? Okay. Right, yes. So Bill is trying to have a gotcha moment, I think, that telling me that pouring it out won't change the ratio, and I agree. I would have to then add water to after I put out the correct amount, right? 6 units of alcohol and 4 units of water, and pick any units you want. So a lot of people were talking about ratios, and Leo is saying, okay, well, I broke the ratio down into the simplest ratio I could think of, and then there you go. Like, I figure out how much water I add. And Bill says, nobody please drink this cocktail. So I forget who had they were wondering when they first saw this, wait, what's isopropyl alcohol? Yeah, let's think about what are the different kinds of alcohol and should we drink this cocktail? All right, so because we are not in an hour-and-a-half long math class, which I usually am in, we are going to pause here, and hopefully you guys are interested in this enough that you'll then talk with each other, talk with your students, and hopefully share all of these different ways and see how they are connected. I really want to point out that a lot of people, a small amount of people shared a lot of different ways. This small group shared a lot of different ways of thinking about it. And I was not able in this time to visualize all those different ways, but that's important as well, how people are visualizing it, how people are thinking about these as ratios, as different ratios, as equivalent ratios. So pausing from our math, now you can take a breath. You did it. We did a little math thinking together. Thank you so much. Oh gosh, nice story, Adele. Thank you for sharing that. Yeah. So don't drink these cocktails. Some extension activities just to share. These will be in the slide. Lots of good thinking to do with this math and these very relevant topics. So going away a little bit, I'll share a little story. Stephen Strogatz is this man at the top picture. And for 30 years, starting in 1977, Stephen Strogatz, who is an American mathematician, maintained an occasional correspondence with his high school calculus teacher. His calculus teacher is below. What he says is, what I now realize was amazing about Mr. Joffrey's teaching was the way he motivated his students. He never competed with us or tried to prove how smart he was. On the contrary, he openly revered his students, past and present, almost to the point of hero worship. He made us want to show him our little insights and discoveries, and he took tremendous pleasure in them. This is a very successful American mathematician talking about his teacher. In contrast, so these two things, making us want to show him our insights and discoveries versus explaining it all and never asking us. These are the two things I'm contrasting here. Teacher has the power. Teacher gives the power to students. Looking at these two prompts, which of these two prompts will get your students to share intuition? Which of these prompts is more likely to, one of these prompts is more likely to convince my students that they can and do think about math now. One of these prompts is more likely to convince my students that they are capable of connecting those thoughts to test math and beyond. I'm curious which one for you guys. How do I convince students that they already do math? Well, if I give, this is my idea, one of my ideas, if I give value to student contribution, for example, using voice, vision, touch, intuition, metaphors, imagery, analogies, then these things become math just as much as deductive, formal, and precise definitions become math. How do I connect the math that they're doing to test math? Well, I also have ideas here. But I want to have a small side note before we end. A common solution to connecting math that students do in real life to test math is making it real world, just changing the context. So I want a quick aside here. This is an actual high school equivalency test word problem. Okay, and so this one is about charm bracelets. Well, my students are adult students. They are over charm bracelets. So I'm going to change the context. A lot of my students knit. Did this create a situation in which students share their intuition? So here they're not sharing their intuition. Oh, now they're sharing their intuition. I don't find that. I find that taking away a lot of context and giving the student an opportunity to share their intuition helps a lot more than simply changing a context. I would take away a lot of context, and I might ask, what do you notice? A lot, you can share anything when you say, what do you notice? When you say, what do you want to, you can talk, students can talk about the difference between isopropyl alcohol and the word alcohol. So how do I connect the math that they're doing to test math? Well, my idea is to just pursue their student contributions in depth, ask for their contributions, and then deal with them. Help them to use their, to define math as voice, vision, touch, intuition, imagery, analogies, just as much as deductive and formal, precise definitions. How do I do this? Honestly, like, I am learning. Everybody is still learning. I have a couple ideas. I tried to model this and try it out with you. Number one, publicly share. So teachers need time to reflect on the potential of mathematical statements, right? And to plan a course of action. So these two teaching strategies might buy you time to validate students' contributions. And one of them is just giving students an opportunity to publicly share their reasoning with the entire class. And this can be virtual, this can be in person, but any way that students can publicly share their reasoning with the entire class. And then the second is to offer a forum. And this is actually really, it's kind of made easier with virtual classes to have a virtual forum for students to record their reasoning for future exploration. And this, even though live classes are really helpful to give students time to publicly share and get that live feedback, you can still have a forum that then gives teachers, you know, time to think through students' reasoning. Do you know how to do these two things? Please, if you do, please share. Giving value to your students' contribution is turning teacher power sort of on its head and pursuing contribution in depth. If you know how to do these things, I really would like you to reach out to share. We're coming up on our time, so please, like, if any of this resonates with you, and if you have an idea for how to do these two things or answer my two questions, please reach out, share with me. I am on Twitter. Math teacher Twitter is a very fun place to be. So if you're not on there, at least you can creep on me at the Kristen and find me, reach out, and help me to answer the questions that I have been working on this year. And so, in conclusion, we have a couple minutes. In these slides, I do have some sources of the things that I was saying in these slides. A really excellent book that that has helped me to give value to student contributions, and that's about it. So, oh, thank you, Dee. So Robert Kaplinski, yeah. He's a great math teacher resource, and thanks for sharing there, Dee. And anything else that you have to say or share in the chat? This group has been a really fun group to talk to. Lots of people taking big risks and sharing, especially in terms of math. I know there's a lot of math trauma, so it's very risky for a lot of people. I am based in Kentucky. The college college system that I currently work for is in multiple counties, but the biggest county is Fayette County, which is Lexington. So thanks, Michael. Joey, Michael's question from before.
Yep, I can put it in the chat if that's easiest. It was, if the worksheets, I'll put it in the chat. Here we go.
Okay, if the worksheets displayed are written as story problems. Okay, you know, Michael, that's a great question. I have ideas. I'm not going to say that I have the answer to that question. And Michael's question is, those worksheets that I kind of displayed before, let me try to get those up. He says, well, if those worksheets were written as story problems, then can students see past this rote arithmetic? My experience, not so much. My experience is these are story problems. So I think what Michael is saying is kind of like what this common solution that I was talking about, common solution that I hear from lots of teachers and administrators. Thank you, Dee. Is to just change the context, make it real world. And that, I mean, it's not the wrong answer. It's not like totally such a wrong answer. But in my experience, it's not the only, like if you do just that does not change students' learning outcomes. If you simply put math into contexts such as these, or change the context to something more helpful or something more relevant. In my experience, it's to take away a little bit of context, and it doesn't necessarily have to be within a story, like you saw from the problem I originally posed, but it's asking for student contribution before anything else, before any explanation. So yeah. Thank you all so much. So Amy, this chat has been great. I'm really glad. Well, I'm gonna make sure this chat is saved. That's a thing. Thank you, Amber. So I will definitely be pulling it out and checking it out. It's been so fun. Illinois, wow, thank you. I'm glad this has been valuable. Any feedback, I appreciate, even critical feedback, positive feedback, anything you liked or didn't like about this session, please reach out, or anything you want to talk about. I'm really into just expanding my especially math teacher circle and adult ed circle, so please reach out.
Wow, thank you, Kristen and Joey, for all of your insights and your interactive session at the Forum for Excellence. This has been a great session, and thank you for allowing us time to think and even be the voices in our own presentation and reflect on our own teaching.